Yes. All right, guys, so we need to start and discuss homework and see what questions you may have. Yes, so next Wednesday, you have 20 questions to do. Those are like the shorter long answers. Those are 3 points each. You got to finish that part that day. And then on Thursday, you have your longer answer type questions, like your trig quadratic equation, like something long like that. Those are worth 5 points each. And then you'll wrap that part up at the end of that day. The next Friday is just kind of used for a makeup day. And then obviously seniors aren't here. So we'll kind of just play that by ear. All right, so on homework. So I'm on the front here first. And general consensus is obviously the trig stuff is harder. Agreed, I warned you that. There's just a lot you have to process through to get those questions right. So first on these couple, so 5 and 6, is there anything you guys want to discuss on those front problems? I am looking here. So anything on your ratio test or converge and diverge or anything with your ellipse? So number 2 would be convergent. Number 3, your ellipse question. Let me move some of these boxes out of the way. I'm sorry, they just tend to all get in the way when I record things. All right, so ellipse, is there anything at all we want to ask on? Yep. Yes. Excellent question. So this right here, if you look underneath your x squared term, the 9 is your larger value. So that means you have a horizontal major axis. So this is going to be your a squared value. And because it's a horizontal major, you're going to add the a value to the x. Because horizontal means add it to the x. That makes sense? And then the other one gets added to the minor. So this one would be your b squared value, and that will get added on there. Anything else with the ellipse, guys? Yep.
Which one is it where you add it to, like which one is it? There's like different rules.
Yes.
That and there's another one.
So when your ellipse has a horizontal major, that means you're adding the a value to the x. And when it has a vertical major, that's when you add it to the y. Yep, so keeping it straight like that. And then your foci always get added onto the major as well. Did that answer that? Good question, yep.
So the foci, the formula is b squared equals a squared minus.
Correct.
Isn't there one where it's a squared plus b squared?
Correct, that's the hyperbola. You are absolutely correct. And the best way to remember these is that they switch. So when you have an ellipse, the signs are the same. So typically they're both positive. So I remember that the foci needs to switch to negative. And when you have a hyperbola, it has a minus in the middle, so that switches as well. Yep, excellent question. These are formulas you guys need to know. And I posted on Classroom a sheet that says memorize. And if I'm not mistaken, those are on there. So you want to make sure you compile that list and start going through those. If you're a flashcard person, that helps. But you want to make sure you know both of those foci equations. So your ellipse is the minus and your hyperbola is the plus. Anything else on that one? Okay. Yep, keep asking, please. Number 4, easy calculator. Number 5, you guys did that on quizzes recently too. So find the 4th term. So you're just going to subtract 1 off that. Yeah, you did fine on that on quizzes. Just make sure you go as far as possible with these and make sure you multiply things out. I don't think it was your class that had a problem with that. 6, write the series in sigma notation. That one is formula sheet. How are those 2 questions? Good? Okay. Yep, I believe you. Those aren't terrible. Then you're given an ellipse in general form. You want to write it into standard form, and then you're going to find everything here again. This one's opposite. This one has the vertical major instead. Okay, so that is when you're going to add and subtract it to the y value instead. And then your formula for your foci is exactly the same as the other side, and make sure you add it to the y. Yeah. Yeah,
7 plus 4, then plus 2
I mean, it's not simplified as far as possible, technically.
So,
yeah, please. I would say please do that. Yep. I get it. It's equivalent, but yeah, you're expected to go as far as you can and make it as simple as possible. Anything on the ellipse, guys? And again, with those radicals, you can just leave them. So no problem there. And then your sketch looks like that. So anytime you have a vertical major, that's when it looks like the, the ellipse that goes lengthwise like that. So it's not the wide one. Good there? Okay, keep flipping. Next, slope-intercept form for parametrics. These are fairly straightforward. You are going to solve both of these for t equals and set them equal to each other. And you've got more of a lot of these to practice again today because you'll see another packet in front of you with all of these topics kind of mixed up. Number 9, anytime you are asked for a tangent line, this is going to be the derivative. So that's definitely worth noting. And you may leave your line in point slope form for this one. For this one, I do not need you to distribute that unless you'd like to. So I would take either answer on that one. And 10, you're going to expand this and find the sum, so you show all your work. Any issues on 9 and 10? Okay, I'll make sure I post these for you guys later as well so you can refer back to them. And then 11 is another one where you want to find the series using sigma notation. So very similar, just extra practice there. 12 is an infinite sum formula. Remember that your ratio must be less than 1 in order to make that happen. That one worked out to just a positive 1. And this formula, yes, is on your formula sheet. And then find the 6th term when you have a power of 10. And then go from there. So 6th term means do 1 less there. All right, how's everything down to 13? Pretty good? All right. Then we have some trig questions with some polar. Oh, I'm sorry, that's a little bit blurry. Let me know if you can't see something. So the formula is you're going to do radius 1 times radius 2 to get the 21, and then you're going to add the angles together. And this is a rare instance where your answers can be written as decimals because you should not know what the cos of 50 is. Same thing with the sine of 50. Those are not exact value questions. So that one is totally okay to just use your calculator for. And if I don't specify where to round, then you can do whatever you'd like. How's that one, okay? All right, down to 15, it's gonna work very similar. So instead of multiplying the radii, you're gonna divide them instead. And this one is a special value. So you have cos of 90 and sine of 90. Where does 90 degrees come from? Triangle or circle? Yep, unit circle. So that means you can use your calculator. You're going to type in cos of 90, type in sine of 90, and then replace those values right there. And then just make sure you write your answer in rectangular when you're done. Either answer is acceptable here too. So you can have the 0 if you'd like. You only write your answer as an ordered pair if the question starts as an ordered pair. So I get that sometimes that gets confusing too. 16 is another example with tangent line. So just, again, I wanted to give you extra practice on that. So same thing as the one a couple questions back. How's this type? Pretty easy. As long as you memorize procedure, those should be very, very simple. 17 is your force question. You did a nice job on this on your last quiz. And again, you're going to take your answer and round it and then use it down below. How are we feeling with the force ones? Pretty good? And again, this is something that you'd probably see like day 2 of your final because these involve obviously a substantial amount of work. All right, that wraps up your first sheet. All right, so now on to your trig ones. And again, don't be shy. If you've got questions, we can go through those. And what the deal with these is they take practice and repetition to really be able to look at them and determine what to do. So if you feel like you're getting close, my recommendation is keep doing them. Take these same problems, take a sheet of scrap paper and redo them again. Or if you want an extra copy of the sheet, there's some right back on the heating unit that I left out for you guys if you want some. So letter A, you're gonna plug in an identity for cotangent. So cotangent has two, 1 over tan or cos over sine. So you have to pick the one that's actually gonna help you. So what I do is before I put cotangent in, I look at the whole problem. This has cosecant. What's cosecant? Reciprocal of sine. This is on your formula sheet, if I'm not mistaken. Yes. If you look right down at the bottom, so bottom left-hand corner of your formula sheet, you have the reciprocal identities for you. Then you're going to do keep, change, flip, and then you're going to cancel. You're going to know if you've done these questions correct because something will simplify. Otherwise, go back and try to kind of restart it. So how's question A, okay? All right, so letter B, you are going to multiply that out and see what cancels. Anytime you get a trig identity back that has a squared on it, this is a Pythagorean identity. That means on your formula sheet, you are looking 3 boxes down on the right-hand side. Anytime you guys get a squared, okay? So use those to help you. Next, so letter C, multiply it out and then rewrite everything that you can. Cosine and just sine, there's nothing simpler, so you're always gonna leave those alone. How's something like C? And again, you guys can get it. You just have to keep practicing it, and then you'll kind of pick up on plug in your identities and get things to cancel there. You stop me where you need interpretations. So letter D, tangent. What's tangent? Sine over cos. What's cosecant? 1 over sine. What's secant? 1 over cos. So your first step is to rewrite everything. Then you're going to do keep, change, flip, and then cancel. So that all consolidates down to just plain 1. So letter E is similar to the one directly above it. You're going to multiply everything out and replace your Pythagorean identity into that one. And again, these are great questions, you know, in the next week because you have no formal homework. I kind of just left it up to you guys to repractice. And again, if you want a brand new clean sheet, there's some in the back, and just sit down and redo them, and then you're going to get it, I promise you. So letter F, you're going to plug in cosecant is 1 over sine, and then keep, change, flip. In this one, all you can do is just leave it as sine squared theta. All right, how do we feel on the top section? Those make sense? Okay, again, you just have to keep doing them and do them over and over until it just clicks with you. Number 2, prove. That just means work with your more complicated side and show that you can arrive at the other side. So you're going to take all of these and rewrite them. So 1 plus tan squared theta is a Pythagorean identity. So that gets plugged in, and then keep, change, flip, and you'll see that you get your sine squared theta. You already know what the answer is on those. You're just trying to make it happen. Number 3 is much quicker. So number 3, you're immediately just going to rewrite these. 1 over sine is cosecant. Cos over sine is cotangent. This is another Pythagorean identity. Again, on your formula sheet, that means 3rd box down. And then you just replace that. So 1 is equal to 1. How are those?
Something like that, can you just combine with 1 minus cos squared?
Yes, you can. Yep, absolutely. You got the same answer, didn't you? Yep. That's the thing with proofs, and I'm sure you remember that from geometry. Often there's many different ways you can do something. Absolutely, as long as you've got that written on your paper, you're good. That was it on the front, right? Yes. All right, next couple are very similar. So prove. So I split them. So I split them and then rewrote everything and did a keep, change, flip on number 4. Number 5, in my opinion, is a little bit more challenging. What you want to look at is the problem as a whole. So if you pull from this, I see 1 minus sine squared x. And that simplifies to cos squared x. Because you want to do anything you possibly can to simplify a problem, and you're replacing 2 terms with just 1 here, so that's good. Always keep looking at this side because that's what you want to obtain. Is there anything on 4 and 5? Okay. So number 6 is formulas. Would you guys agree something like 6 is pretty reasonable? Those are not difficult? Okay. Draw your pictures, Pythagorean theorem to find your missing sides, and please leave those as fractional answers. So again, that's just simply setting up your picture, writing your formula correctly and going from there. Number 7 is your formula, but it's off by a negative, so you want to pop the negative in front there. I didn't really give you anything where you have to do that on your final though. If you're good with this one, then that's sufficient. And then number 8 is very similar to number 6 above. Picture for angle A, picture for angle B, and then formula sheet. And then same thing here. So for number 9, picture, picture, formula sheet. How do we feel with those? Pretty solid? Okay, yep, and keep those fractional answers. All right, over to, let's see, your last page. I saw a lot of blanks on number 10. So when you guys see exact value, let me make you a list, just to help. These are the ones you have to memorize. Exact value, what angle should we know? 30, yep. 45, yep, she's right. What else? 60. Okay, what else can you use? Anything off the unit circle. So these are some choices to pick from. This is like your bank to choose from right there. And then you get to the ones that are a little less obvious. And these are the ones where when you subtract, you obtain a reference angle that is those numbers. So for instance, if I have 150 degrees, that would be 180 minus 150, which is 30. So that works. Let's give you another one that works. Yes, excellent. 135 works. Quadrant 3, 210 would work because 210 minus 180 reduces to 30. What else? 225, that works. Quadrant 3, 315, that works. 330. I think that's probably a big enough list for you. Yeah, I find it hard to believe you couldn't find one of those pairings here that that works for you. So now that's how you go about these. You look at 75 and you say, how can I make 75 happen? And don't panic. Sometimes there's 2 ways to do it. So how can I make it happen? I can do 30 plus 45 or 45 plus 30, doesn't matter. So this is the formula A plus B. So then you look at your formula sheet. And now here's where you have to know these. So where you see cosine of A, you have to know at this point that that is radical 2 over 2. Cosine of B, so that's cosine of 30. You have to know, again, that that's radical 3 over 2. Sine of A, so that sine of 45 is radical 2 over 2. And then sine of 30 is 1/2. All right, so you definitely in the next week want to sit down and make sure you memorize those. It's something that typically when you come into this course, you would have had memorized from last year anyways. Okay, but I know you guys obviously had an off year last year. So now letter B, I'm trying to make negative 15 degrees happen. So I look at that list and I say, how can we make it happen? So one example is 30 minus 45. And then you look at your formula sheet and you find the formula for tan of A minus B. How are these? A little bit better? And again, on your final, feel free, just write a big list on the top there to kind of pull from. And then if you look through these answers, you're gonna see they all kind of look the same. So they all pretty much have those radicals that remain. Next, 195, that's 150 plus 45. That one's tougher because again, you had to make use of that 150, which reduces down to 30. And again, as soon as you leave the first quadrant, you have to account for the fact that sine is going to be positive here and cosine is going to be negative. So this is ASTC. 105 degrees is 45 plus 60. So that works there. And that's that top section. How do you guys feel on those? Okay? Better? Okay. And again, anything that gave you difficulty, you've got a week to just sit down and practice, because my guess is you probably don't have any other final exams, right? Spanish, of course, Spanish, and history, yep. I'm sure history is easy for you though, right? Because your AP is done. You got that, Jake. You got that. It's just vocab, isn't it? Okay. Living environment, common sense, right? I guess. All right, so number 11. 11, draw yourself a picture. And then again, it's just formula sheet. And when you get down to letter B, and you look at your formula sheet, cos of 2x has 3 identities. So you can choose whichever one you have enough information to plug into, but your answer should still be the same. And then tan of 2x, that's another formula. And again, once you generate your picture up there on the top, then you're good to go and you just plug those in. How's that one, okay? All right, trig equations. So these are the type that can yield a maximum of 4 answers. So we have angles between 0 and 360 that satisfy 9 cos squared theta minus 4. Think of this as 9x squared minus 4. So this is difference of 2 squares factoring with a trig function. So then you're going to split it and you're going to plot these. So these are both going to be quadrants 2 and 3. You're going to use your calculator, do second cosine of 2/3, and then you get your answers. And once again, I didn't specify where to round, so whatever you did is fine. That one makes sense as far as setup goes? Okay. And then the back questions remain. And again, I have more trig ones for you today too. Was there a back? Yes. Just 3 of them, right? Yes. All right, so your last 3 homework questions. Find your angles here. So this one's all set up good to go, but this one's not dots factoring anymore. This one is a GCF. I tried to give you one of each. So this one is GCF factoring, and you have tangent function twice. Again, you can have 4 answers for these. Doesn't mean you have to though. So your first 2 answers are going to be off unit circle because that gives me a value of 0. And then your second answer here, tangent is negative quadrants 2 and 4. And that one I rounded to the nearest 10th. How's something like that? A little bit better? James, these are posted. You don't have to take a picture that far back. Can you even read it? Oh, okay. Yeah, these are online. That's okay. That's why I'm telling you, so you could actually look later and be able to read it. All right. I can't imagine that's a good quality image. All right, so 14. 14, the problem is when you look at this, you have a cosine function and a sine function. So you can't solve with both here. You need to do a substitution. If you look at your formula sheet, cos 2 theta. Cos 2 theta is the big box on the bottom right-hand corner. And you will notice that there are 3 identities for it. But you want to plug in the one that's actually going to help you. You want the one that just gives you a identity in terms of sine. So you plug that in, substitute. You may do AC factoring or quadratic formula for this one. Okay, both are going to give you the same exact answer, but this one was factorable. I have a feeling you're probably more comfortable with quadratic formula with those than the AC factoring, and there's nothing wrong with that. That's fine. They're both algebraic methods, so you're good. Full credit on both. This one only had 2 answers, 30 degrees and 150. And last, quick one. Sine of theta over 2, that is a half angle identity. Cos of theta, so positive 3/4 first quadrant. Sine is also positive in the first quadrant, so that's why I only use the positive, and then you just plug it in. So that answer rationalized would be radical 2 over the 4. Again, no decimals, please. All right, is there anything left on homework, guys? And again, my recommendation is take the time you have in the next week and go back through any of these that gave you difficulty. But I have a feeling once you see more of them today and tomorrow too, they're going to just continue to improve. We're good on homework? Yep. Yes, all of these have been. This one is too right now. Yep, you can absolutely go back and listen to anything that you want or jump through things as well. Yep, tomorrow's will get recorded too. It's nice you guys have that available to you, actually. All right, we're good with homework, you promise? If you think of something tonight too, we can obviously hit those back again. So let's just keep practicing. So on your desk, I placed one more packet, and these are just your problems kind of all mixed up at this point. There's some trig, there's some conics, there's some polar, but have your formula sheet in front of you. We'll go through these nice and slow, start them today, finish them tomorrow. And again, anything that you want extra copies of, just blank copies to go back and re-practice, just ask, because I will make some extra in case you want those. So number one is just identify your conic here. So choices for this. You can have a parabola, a circle, ellipse, or hyperbola. Anyone remember this one? Ellipse, exactly. And I'm gonna write your reasons on here too, because I want you to have a nice thorough review and get as much as possible stuck in your head. So this is an ellipse. Your reasoning, your A is not equal to your C. However, they are the same sign. If they're the opposite sign, that's where you have your hyperbola instead. All right. So number two, and yes, you do have some questions that are that quick. So number two, your limit. And again, if you find that you're getting really confident with these, you don't have to show this algebraically. So algebraically, you would take every single term, you would divide these by n squared. Again, this is not required work at this point. And then I'm gonna go over, and then 2n over n squared. And then again, if you want, you can go through this. This approaches 0, and then the bottom also approaches 0. So this limit does not exist. Perfect. Again, nice, quick, and easy. Okay, so number three, use trig identities to write this as one angle. So you're gonna take your formula sheet and you're gonna find on the right-hand side, where do I have a formula that says sine of A, cos of B with a plus in the middle? Because usually that's enough to get it. So that's what you wanna look for. So on your formula, sine, what did I say? Sine A cos B. So would you guys agree that's the first one? So this is sine of x plus y. So this is sine of A plus B in our case instead of x and y. So all I need to do is plug them in. 90 plus 32. So my answer is the sine of 122. And is that an angle you're supposed to know? No, so you leave it, done. Number four, find the equation of a circle in standard form. So here's a formula. Technically you have to memorize this, but at least just how to sub into it. Circle equation is x minus h squared plus y minus k squared equals r squared. But again, that doesn't have to be written on your paper. All you need for an answer for full credit is just this. So x minus 3 squared, and then plus, switch your sign, y minus 4 squared equal to 100. Yep. Did I say that? I'm sorry. I saw that on there too. The 4 got kind of, your negative sign's a little bit small. Yep, just make sure you have the plus sign in between here. And make sure when you take your radius on the other side, don't write 10 squared. Please actually multiply that out and write 100. How's that one? Easy too? Okay. So now number 5, write the complex number in polar form. So we currently have x plus yi, and we want to change this into polar, which is r cos plus I sine of theta. Okay, so that's what you're looking to get when you're done. So you're going to look at the formula sheet, and what's the first variable that we need? The r. So you go to your formula sheet and you find that r is equal to square root of x squared plus y squared, and you sub them in. So I'm going to go here, square root of 3 squared plus my coefficient, which is 1 squared. So r is equal to the square root of 4, which is equal to 2. Okay, so I already know that this is 2, cos plus I sine, and now I'm going to find that. So over to your formula sheet again, and you're going to do an inverse tan function for this. So I have a positive x and a positive y, so over and then up is here. So if you want to label this, you can, you don't have to. And I'm going to do an inverse tan function. So tan inverse of y divided by x. All right, guys, go ahead, type that in. It should be one of your special angles though. So second tan of 1 over radical 3 gives you 30, good. And then done. You can write the expanded version if you want to, but that's the fastest way. All right, how's number 5, okay? All right, so number 6, you just did this. Well, this was last week, but again, reviewing kind of everything here. Ordered triple notation though when you're done instead. I'm gonna go I, and then J, and then K, and then 5, 10, 15. And really the only thing I've noticed that sometimes gets off on these with you guys is the signs. So just go slow, use your calculator if you need to, but obviously tons of partial credit if you make those sign errors. So you're gonna set this up. I'm gonna go I, and then I'm gonna go 10, 3, 15, and negative 2. And then I'm gonna switch my sign in the middle. So minus J. I'm gonna go 5, 7, 15, negative 2. And then plus little k. So that would give me 5, 7, 10, and 3. And then you're gonna find these. So always make sure you start with the major diagonal. Again, you guys have been doing that. So I have negative 20 minus 45. So this first one is negative 65i minus j. And this one is negative 10 minus, is that 105? No, can't remember what that is. 7 times 15. No. Say it again. Oh, it is. Thank you. 105. All right, so this would be minus j. And again, if you think you're going to make sign errors, you can do little things like this and then kind of keep going just so you don't, again, make that mistake. And then I have plus k. And then I'm going to have here 15 minus the 70. So this would become minus 55k. And I've just got one little thing here to clean up. So my answer is an ordered triple is negative 65, positive 115, and negative 55. How are those? Still okay? Good. Yep. You have a lot of material on your final. It's not all just the trig stuff. So a lot of it are, quick problems that you're fairly confident with. All right, find all of the terms of the expansion. So this is only a power of 3, so you probably don't have to write too terribly small. So I'm going to start this with 3, choose 0. And then we're going to go 2a to the third. And then you're going to go negative 2, don't forget the negative, to the 0. First exponent goes down, second exponent goes up. 3c1, 2a to the second, negative 2 to the first, plus 3, choose 2, 2a to the first, and negative 2 to the second. One more. 3, choose 3. 2a to the 0, negative 2a to the 3rd. All right, so do it up. So 3, choose 0 is 1. This is going to be 8a cubed. Anything to the 0 is 1. 3, choose 1 is 3, correct? Someone knew that yet? Yeah, I was going to say that's 3. Thank you. And we got 4a squared. And then negative 2. And then this is another 3. And then times 2a. And then times 4a squared. And then lastly should be 1 times negative 8a cubed. All right, so last and final step here. I have 8a cubed minus, so 12 times the negative 2, so I have 24, and then a squared. And then next I have 8, and then another 24. And this is going to, what did I do here? I'm sorry, did I put an A randomly? I'm sorry. I'm sorry, my contacts are driving me crazy lately with these allergies. I'm sorry. It all starts to look the same, doesn't it? There we go. Get rid of that. Perfect. All right, so we have positive 24, and I have a squared. Except for now, that's going to become a negative, isn't it? Oh, nope, we're good right here. So I have a, back it up, sorry. Okay, so I'm just going to have a 24a on this one. So 24a. All right, and then your last term is just minus 8. Okay, how do we feel with the expansions? Pretty good? And again, at this point, I'm sure you know you're probably going to get one of those. All right, a question like number 8. My guess is this one's a little bit tougher to remember. Is that true? Okay, so I want to use de Moivre's theorem, find all roots for x cubed equals negative 64i. Answers can be left in polar form only. So when I have a x cubed, how many answers am I going to produce here? 3. So I'm going to have 3 on this one. So I begin, and I need to take this from rectangular, and I need to put it into polar form first. So I'll give you a lot of work over here, but you can feel free to skip some of these steps if you don't need them. So basically, this is what I have is x plus yi. And then I would undo this. And again, you don't have to show this part if you don't want to. And that would give me x is equal to, and I rewrite this as an equivalent root to the 1/3 power. Okay, so from here, we need to change this into polar. So I want it to say r cos plus I sine of theta to the 1/3. So I'm going to plug into this in a second. So I need to find this, and I need to find this. Formula sheet again. R is equal to square root of x squared plus y squared, which again, you can do in your head if you'd like, because it's 0 squared plus 64 squared, and then the square root of that. So R would just be equal to 64. So I have that number now. So now I'm going to find theta. So I'm going to plot 0 and then negative 64i. So I'm 0 and then negative 64 is here. So this is at 270, no work involved. Okay, so now you're going to look at your formula sheet. On your formula sheet, this is, I'm looking, left-hand side, 1, 2, 3, 4, 5, 6 boxes down. Do you guys see the one that goes 1/n? So that's what we're looking to do here. So R raised to the 1 over N. So this is 64 raised to the 1/3. So I distribute it. 64 raised to the 1/3. And then cos plus I sine of 270 times 1/3. All right, so my first answer is 4 cos plus I sine of 90. And now I'm going to get the two others, and this is the easy part. So I have 3 roots altogether. So the formula is 360 divided by n. So 360 divided by 3 means I am going to add multiples of 120. So first, 90 plus 120. So this is 4 cos plus I sine of 210. And then last, cos plus I sine of 330. All right, and then done. So there is your answer there. How do we feel on those guys? Pretty good? Okay, I think I'll have you do, we'll do maybe one together and then I'll give you the rest of the time and you can work on these and we'll go through the rest tomorrow. But then you have an opportunity to kind of try some of them on your own and see where your questions are. So number 9, we'll do this one quick. So you have a force of 120 newtons. So what are we going to draw for this again? Yep, parallelogram. $120, and we want to 70 degrees. So I'm sorry, 70 newtons is our other, and our angle is 105 degrees. Again, make sure that you don't use that one. Instead, you're going to go up and use your top corner because those are consecutive interior angles. That adds to 75 there. So this one's 120 and then 70. All right, so find the magnitude of the resultant force. So I hope at this point, you know this is formula sheet. And geometrically, you have a side angle side relationship. So what law is side angle side? Law of cosines, perfect. Here's your resultant force. So we're gonna set it up. So you're gonna do x squared or whatever letter of your choosing equal to 70 squared plus 120 squared minus 2 times 70 times 120 times the cosine of 75. And again, it's all just simply calculator work at that point. So you're gonna place everything in there. Again, you just did the sun quizzes. I didn't see anyone struggle with calculation. So this answer is 122.28. Okay. Everyone fairly confident there? Okay, good. So then lastly here, letter B, I want to now find the angle formed by the smaller force and the resultant to the nearest 100th of a degree. So smaller force and resultant. So that's right here. So now you're going to do law of sines instead. So I'm going to do 120 divided by the sine of y equal to my side length of 122.28 and then divided by the sine of 75. Cross multiply solve. Again, just take your time. So to the nearest 100th of a degree, you should have an answer here that comes back as 71.43 degrees. All right, so I'm going to stop there for today. And again, you know yourselves best. Tomorrow, we're going through the rest of these. If you think that it would be helpful to do some of these tonight on your own on like scrap paper, then absolutely please do that. Then you can get your questions addressed tomorrow as well. Okay, but you don't have any formal homework between now and when you return next Wednesday, other than to just prepare yourselves, study, and bring your textbooks back. Is that okay for now? We feeling good? Perfect. But again, you've got a couple minutes to work right now.